Previous class we already discussed about the 8085 pinout diagram of the 8085 microprocessor. We discussed each and every pin of 8085 microprocessor and their working principles. Now in this session we mainly focused only the timing diagram of 8085 microprocessor. So before we discuss about the timing diagram of 8085 microprocessor, it is very important to know that in 8085 microprocessor the instruction cycle is divided into two parts. One is opcode fetch cycle, another is execution cycle. And execution cycle also divided into two parts. One is a read and one is a write operations. That means if it is a memory read operations, then maybe execution cycle is a memory read execution cycle, or maybe memory write execution cycle. If the microprocessor is communicate with peripherals, then maybe it is a IO read or IO write execution cycle. So first we discuss about the opcode fetch cycle. So first of all discuss about the timing diagram of opcode fetch cycle. It is very important to know the internal architecture. That means during the opcode fetch what will happen in 805 microprocessor. So this is a basic structure of the 8085 microprocessor. We only focus on those part which is involved during opcode fetch operation. So in the 8085 microprocessor, maybe you just think in that way, then there is a instruction which is present in external memory, because whatever you just programmed or whatever you just write any kind of, if you write any kind of operation or program, everything is saved in external memory. Think in that way that from in external memory 2005H location there is a instruction whose opcode is 4F. It is also a hexadecimal number, that's why we use H. What is opcode, what is operand, we will discuss later. But opcode is means, but very short we can describe the opcode. Opcode is means it is a instruction. Through opcode microprocessors understand that which kind of operation microprocessor will perform after execution this operation, after execution this opcode. Or maybe the programmer, if the programmer is want to add a two number, the programmer is write an instruction such a way that this instruction can help, can provide the, or maybe in that way the instruction can help you to understand the microprocessor what the user want. So maybe you think in that way, if I want to add a two number, we use a add instruction and the opcode of the add instruction is 4F, which is present in external memory at location 2005H. So first microprocessor, this instruction or maybe the address of this instruction is first saved in program counter. We already discussed this is a special purpose register and it is a 16-bit register because it's hold the address of any kind of data. So that's why it's a 16-bit. So whenever the opcode fetch cycle performed or start to process, then program counter is generate a address of add operation. That means 2005H. This address, through the address bus, this address is passing from program counter to external memory through address bus. External memory then takes some time to decode the particular or locate the particular position or particular address. After successfully define the proper address or proper location, and in this location there is a 4F data. That means this is a opcode. This opcode or data is passing through the external data bus which is connected through microprocessor. That means this external data bus is connected between microprocessor and external memory. This external data bus, from the external data bus this data is flowing or is coming from external memory to microprocessor internal data bus. The internal data bus is connected with ALU, with instruction decoder and the several register. So in opcode fetch, first the data is coming from external memory to instruction decoder, and instruction decoder is decode the data, because 4F is we know this very well, the programmers know this very well, that 4F means these are add operations, but microprocessor can't understand whenever it not be decoded. So at first the opcode is decoded by instruction decoder. After decode the instruction, microprocessor generate through the control logic, microprocessor generate a various control signal which can control the further operation. Maybe here the read control signal is active after decode the operation. So that means in decode section or decode operation, there is a few block is maybe used to perform decode operations. One is program counter, then address bus, external memory, external data bus, internal data bus, instruction decoder, control logic. So this is a that means this kind of things is happen, maybe this kind of things will happen whenever the opcode fetch is performed. So in opcode fetch cycle, mainly in 8085 microprocessor, opcode fetch cycle is fixed. It takes 4 T state. That means the time required to perform the opcode fetch operation is mainly a 4 T states. This means there is a 4 clock pulse. We draw first the 4 clock pulse for 4 T states. For first clock pulse, what will happen? The address bus is active, because the address bus carry 2005 address. So out of 16 address line, upper A15 to A8 line, these two line mainly hold the address of higher order. That means out of 2005, only 20H higher order address hold the higher order address bus. The higher order address bus hold the higher order address 20. For first T state, lower order address bus as well as a data bus will hold the lower order address 05. The combine of these two address bus, this is a total address bus, this is a combination. So this address bus hold the address of 2005H. During this, ALE is active, because ALE, whenever we already discussed, the ALE is a particular special purpose control signal. If it is active, that means if it is 1, then microprocessor lower order address bus hold the lower order address. So lower order address hold the lower order address, that's why ALE is 1. Simultaneously, IO by M bar S0 and S1, this is a status pin. Opcode fetch is a memory operation, that's why IO by M bar is 0. S1 and S0, these two status pin, if it is 1 and 1, we already know that this, if this pin is 1, then it is a opcode fetch operation. That means entire 4 T states, these 3 pins value is fixed. Now we are talking about the read operation. Whenever microprocessor read signal only active whenever data bus or lower order address bus is behave as a data bus, then read and write signal are active or inactive. In that case, for first T state, lower order address bus behave as a address bus, that's why read is inactive. Read bar is 1. After decode, this is a unspecified time, because microprocessor after the address is coming from program counter, external device require some time to address a particular locations. So this time is required to address a particular locations. After external device locate a particular location, the data is coming from data bus. That means the lower order address bus now carry the data. That means lower order address bus is behave as a data bus. So it carry 4F, that means opcodes, and then it take 2 T states. Then whenever the lower order address bus is behave as a data bus, ALE is active low, and read bar is active, because this means it is active low. This means 0 means active, 1 is inactive. So this is active whenever data bus hold the data. After the data is coming from external memory to internal memory, microprocessor need some time to decode the data and generate the control signal. That's why this time period is unspecified, because microprocessor require some time to perform the operation. After performing the opcode fetch, microprocessors understand the meaning of the instructions. If the instruction is add operation, then microprocessor further perform the addition operation, maybe take some data from external memory or maybe internal register, and then they perform some task. If the microprocessor is understand that it is a external or peripheral operations, then they just take the data from peripheral device, and maybe the execution cycle is a maybe IO read or IO write. So this kind of thing is happen whenever microprocessor perform or execute any kind of operation. So now we focused, before we discuss about the timing diagram of memory read or memory write, it is a very important to know the instruction itself, because if we don't know the instruction of 8085 microprocessor, it is creates some problem or creates some kind of confusion. That means the execution cycle is memory read or memory write or maybe IO read or IO write. So before we discuss about the other timing diagram, it is important to know the instruction set. In 8085 microprocessor, the opcode or maybe data is a 8-bit, and microprocessor opcode is also 8-bit. And if the microprocessor opcode is 8-bit, that means microprocessor have 2 to the power 8. 2 to the power 8 means 256 instruction. In 8085, the total 256 instruction is present. Out of 256 instruction, we first focused a very important instructions. So in 8085 microprocessor, there is the instruction is categorized in the 3 way. First, their size. Second, their performance. Third, address. That means data is present in microprocessor registers, or data is coming from external device or external memory. So there is a 3 type we can categorize the total instruction set. First, we discuss about their size. In 8085 microprocessor, the instruction, there is a lot of instruction whose size is 1 byte. 1 byte means 8-bit. So first of all, instruction, there is a 3 category. One is a 1 byte instruction, 2 byte instruction, and 3 byte instruction. Maximum the size of the instruction is 3 byte. In 8085 microprocessor, 1 byte instruction means the size of the instruction is 1 byte. Example, ADD B, move A comma B, CMA, INR. We discuss the operation of each and every instructions. Next is 2-byte instruction. That means those instructions, size of those instruction is 2 bytes. That means example of 2-byte instruction is MVI A comma 01H, ADI B, ADI F0, etc. And 3-byte example of the 3-byte instruction is LDA 2000H, LXI H30F0H, in that way. So it is a very easy to understand out of 256 instruction which instruction is 2-byte, which instruction is 3-byte, or which instruction is 1 bytes. Those instruction, there is an address is connected of those instruction. That means the size of those instruction is 3-byte. You can understand very well because look at this instruction. There is an address is involved within the instruction itself. That means the address of the microprocessor is 2-byte. That means 16 bit. And another is opcode. In 8085 microprocessor, opcode is 1 byte. So the size of the instruction is 3-byte. For 2-byte instruction, the data is connected with the instruction itself. That means each and every data of 8085 microprocessor is 1 byte and instruction is 1 byte. So altogether 2 byte. For 1 byte instruction, there is a no data, no address is connected with it. That means the instruction is 1 byte. In that way, we can very easily categorize the whole instruction set. In 8085 microprocessor, there is a 74 instruction set and total number of instruction is 2 to the power 8, mean 256. In 8085 microprocessor, according to their operation, the instruction is again categorized several way. First of all, first type of instruction is a data transfer instruction. Data transfer instruction. Those instruction transfer or load the data, the instruction is called a data transfer instructions. That means move A comma B. This instruction is a data transfer instructions. Means the meaning of this instruction is very simple. The data is transferred from B register to A register. This means the data is transferred from B to A. Again, LDA 2000H means 200H is an address. This is a 3-byte instructions. It is also a data transfer operation because it load a data which is present in 2000 location, and this data is transferred from this location, external location, to accumulator. That means the data which is present in 200H location, which is transferred from this point to accumulator itself. So this is also a data transfer operations. There's a lot of data transfer operation is present in 8085 microprocessor. Second category is arithmetic operation. Arithmetic operation. That means those instruction is involved, or those through those instruction microprocessor can perform any kind of arithmetic operation. This instruction is called a arithmetic operation based instructions. Examples. Example of this instruction is add B, means microprocessor add B register and A register, and result of the addition is also stored in accumulator itself. So microprocessor add B, this is a 1 byte instruction because there is a no data or no addresses connected with the instruction itself, and B means the data, one data is present in B register, one data is present by default in accumulator, the accumulator is add with B and data is stored in accumulator itself. Maybe it is better to write in that way. Subtraction, SUBC means A is equals to A minus C. There is a addition and subtraction is a two main instruction, because by using this instruction we can perform any kind of arithmetic operation like addition, subtraction, multiplication, division. That means whenever we need multiplication we can simply use the addition successively. Same thing is applicable for division, we can use subtraction itself. Next is logical operation. That means in 8085 there is a lot of logical instruction which is perform any kind of logical operation like ANDing, ORing, XORing, NOT, inverter, etc. Example of the logical operation in 8085, ANI05H means ANDing of perform the that means you can say A is equals to A and 05H. That means this instruction 05H is a data, this data and one data is present with instruction itself and one data is present in accumulator, and after performing AND operation the result is stored in accumulator. So ANI, then XRAA, XORing operation, maybe CMA, complement, this is an invert NOT operation, maybe ORA, OR operation, there is a four kind of operation, AND, OR, inverter and XOR. By using this basic operation we can perform any kind of logical operation bit by bit. Next operation is branch operation, branching in 8085. Next is branching operation in 8085 microprocessor. There is a two kind of branching, one is a conditional branch, one is unconditional branch. If we want to jump from one position to another position, this kind of branch operation is very important, and whenever we perform any kind of loop operation then also we use this kind of jump operation. Unconditional jump, unconditional branch operation, we use JMP address, whatever address you mention, microprocessor jump from particular point, particular position to this address. And another is a conditional jump. In 8085 microprocessor there is a 5 conditional jump. One is JZ, jump if zero flag is equals to 1, JNZ, jump if zero flag is not equals to 1, JNC, JC, JNP. In 8085 microprocessor maximum time we use this 4 jump instruction out of 5 kind of jump instruction. So this is a branch operation, and another is a machine control operation. There is a 2 machine control operation, one is halt and NOP. This is a 2 machine control operation. Maybe halt is better to say the machine control, because in halt operation microprocessor complete their task. Whenever the halt instruction execute, microprocessor stop the performing any kind of operation. So this is a basic category according to their operation. Next class we will discuss about the addressing mode and other kind of operation.